Hello there and welcome. My name's Mike from Hello Renewables Limited. I pretty much in appointments get asked the same 10 questions. So today I'm going to run through them questions and hopefully give you guys a little bit more of product knowledge and insight to what we install and how we do it. The top 10 questions are: what is an air source heat pump? Feels like a pretty good place to start. How do they work? What different types of system can be installed? How much do they cost? Can I get help to, help pay for the installation? How much are running costs? That's quite an important one. I get asked that a lot. How can I make improvements to my property to make the heat pump more efficient? How big are they and what do they look like? Where can they be fitted? It's a massive stumbling block. What other renewable products are on the market today? So let's get started. What is an air source heat pump? An air source heat pump is a product which sits externally to the property and it extracts energy from the ambient air. And then it transfers that energy into either water for your domestic use, radiators, etc., or into air, which is more of like a traditional aircon system. So how do they work? I'm not going to bore you too much with the science, so this is going to be the more simplistical answer to how they work. But the outdoor unit has a big fan and it blows ambient air over a heat exchanger. Now running through that heat exchanger is a refrigerant. Sometimes it's R410A on more of the older systems, but the majority of the new systems use an R32 refrigerant. I'd like to use water as an example. Water will boil at 100 degrees and it will freeze at 0 degrees. Well, refrigerant will boil at minus 50. So let's say on a spring day, it's about 5 to 7 degrees outside. How is that going to heat my house? Well, using that ambient air at 5 degrees, it's going to boil that refrigerant pretty quickly, which will then transfer that heat into your water for your radiators and hot water cylinder. So we install 4 types of system. Number 1, the low temperature monoblock. Number 2, the high temperature split system. Number 3 is the low temperature outdoor unit with an integrated heat pump and unvented cylinder. And number 4 is the hybrid system. The type of system depends on the property type and also the space you have available in the property. So the first one is a low temperature monoblock. This is an all-in-one heat pump. It has the fan, the refrigerant circuit, the control board or the printed circuit board, and all of the hydraulics required for the heating system all in one box outside. So if the indoor space is quite tight, then this is a good way of minimising products inside the property. So that's all that's required inside is the hot water cylinder and a few valves and vessels and bits and pieces. The second one is a high temperature split system. These are generally more suited to a medium to large property. It has the fan on the outside along with the refrigerant circuit, but this system is a split system. It's called a hydro split. On the inside there is a hydro box. It's about the same size as a boiler, and in there it has the PCB and the hydraulics required for the heating system. This system needs to be paired with a hot water cylinder. Just a little bit on the hydro part. A hydro split means that there is water circulating between the 2 units, and there's also a refrigerant split which has refrigerant circulating between the indoor and outdoor unit. Thirdly, we have the low temperature heat pump with an integrated unvented cylinder. This heat pump is ideal for small to medium sized properties where there's a minimum space inside and the heat loss of the property doesn't exceed 8 kilowatts. It's a smaller outdoor unit, roughly the same size as a sort of traditional aircon unit, and inside the property I kind of call it a tower unit, which again has the PCB and the hydraulics, but it also has a built-in unvented cylinder. So it's like an all-in-one solution. The cylinder comes in either 180 litres or 230 litres, so it can suit most properties with 1 or 2 bathrooms. And the fourth is the hybrid system, which uses a combination of renewables and gas for your heating and hot water. again with the smaller outdoor unit, but it has a highly efficient boiler inside the property, piggybacking onto the renewable side. In some instances, it could be a like-for-like combination boiler swap. They also cleverly manufactured the product so it can be used either as a combination boiler or a standard heat-only boiler, so you can use a third-party cylinder. This is a great sort of introduction to heat pumps, with the customer still keeping the safety net of gas, but want to try and dip their toe into the renewable world. How much can it cost? This is a tricky question. Obviously, every installation is unique and the materials used are quite expensive, so it can significantly vary the cost. If we use the 4 types that we install, a Daikin hybrid or tower style unit, it averages around about 9,000 plus VAT, and the monoblock and the high temperature unit can average around about sort of 12,000 plus VAT fully installed. Just a side note, the VAT can vary depending on your circumstances and government policy at the time. For example, if you're over the age of 60, we can do a 5% VAT and it's 0% on new builds. Currently, there is the RHI, or the Renewable Heat Incentive. It's a government incentive where you get paid for the amount of heat generated by your system. It's paid on a quarterly basis for 7 years. My understanding is that there will be a new scheme called the Clean Heat Grant being implemented in April 2022. The precise details have yet to be published for that, but more will come in a later video. There's always a question about running costs. I'd like to use a real life example. We took a 4-bedroom detached property, double glazing. We understood before the heat pump was installed, the gas boiler used around about 150 kilowatt hours at 3p a kilowatt for gas, equaling about £4.50 a day. After the heat pump was installed, it used about 35 kilowatt hours at 13 pence per kilowatt hour for the electricity, about £4.55 that day. In essence, the heat pump is 3 times more efficient, but the electricity is more expensive. It's when you start to install solar PV and battery walls to sort of drive down your cost for electricity, that's when you can make some significant savings, removing the need for fossil fuels, which to me is a win-win. I often get asked, how can I make my house more thermally efficient? I think the answer is quite simple in loft insulation, heat rises, so it is a straightforward answer and quite a simple procedure. Have you got double glazed or even triple glazed windows, cavity wall insulation, and just try to remove any drafts from old doors and windows. Just try to get your house as thermally efficient as possible to maximise benefit from your heat pump. Just a side note, if you oversize radiators, we can reduce the flow temperature, and the lower the flow temperature, the more money you're going to get paid for your RHI. Well, they say a picture says 1,000 words, so let me show you some pictures. Firstly, we've got the monoblock, the low temperature. They are 460 millimeters deep by 1400 wide, 870 high. They've been specifically designed to fit underneath a kitchen window. The high temperature unit, the Daikin Altherma 3 HHT, the 533 millimeters deep by 1270 wide and just over a metre, 1003 millimeters high. This model is slightly taller than the monoblock with the black grille. Some say it's slightly more pleasing on the eye. And then finally the hybrid and the tower unit. They have the same spec outdoor unit, about 388 millimeters deep by 884 wide by 740 high. They all need to be installed 100 millimeters above the average snowfall, and they all run around about 60 decibels, which is the equivalent of a household fridge. So where can the units be fitted? I think finding the correct location for the outdoor unit is very important. Ideally in a back garden or a wide side return down the property. Personally, one of the most important factors is what's in front of the unit. Given that this unit can exchange 1.5 million litres of air an hour, if there's a wall in front, it's going to hit that wall and then recirculate around the back. The unit will extract around about 7 to 12 degrees of ambient temperature on every pass. So let's take an average of 10 degrees. If the air going in the back is at 5 degrees, it's a beautiful spring day, it might be coming out the front at -5. If it hits that wall and recirculates into the back of the unit, it's now going to come out at -15. And as you can see, it's not going to take long for the unit to completely frost up, meaning it's going to have to do a defrost cycle, and then it's going to remove the heat from your property. So location is always key. If possible, we always install it with an unobstructed frontage. The smaller units can be wall mounted, which obviously gives more options about the location. And finally, there are 2 other renewable offerings in today's domestic market, which complement your heat pump system to move you further away from fossil fuels. The first one is solar PV, which generate electricity to remove the use from the grid. You can also charge home battery walls with solar PV, removing further load from the grid. And secondly is solar thermal. This will harness the solar energy to generate thermal energy from your hot water systems. Thank you for watching, and I hope you found it useful.
Yep.
What's
the question?
I don't know. How does it work?
How does it work? What's the question?
I have no idea. I started before, I have no idea what it is. Yeah, we've come so far today.
No.
Right. Smashed it.